In this video, we're going to talk about an important application of exponential growth and decay, which is the compound interest formula. So far we've been solving exponential growth and decay problems using this formula, y equals a times 1 plus or minus r to the t. We can actually use a different variation of this formula to perform calculations that involve investing money in a bank account. So what we do is we talk about this idea of compound interest. What happens when you invest money in a bank account is the bank will give you a certain percentage of the amount of money you invested as interest. Okay, so they're basically paying you to have money invested in their account. And so you can get interest based on the amount of money you initially invested, but you can also earn interest on past interest that you have. And that's what this idea of compounding is. So that means that you get interest not only on the principal, which is your initial investment, but also interest that you've earned in the past. So how do we do calculations with compound interest? We have to take our exponential growth formula, that y equals a times 1 plus r to the t, and we have to modify it even further. So a, as always, will represent the initial amount. So in this case, how much we deposit in our account. R will represent the interest rate, okay? But the interest rate, remember, it's a percentage we have to convert to a decimal, but we have to take it and divide by this factor of n. And the reason for that is because interest rate is given to us annually, okay? So it's per year. But the compounding may happen more than once per year. So if the compounding happens more than once per year, we have to add in this factor of n that represents the number of times the interest is compounded per year. Also, t in the exponent represents the time in years. Well, if our interest is being compounded more than once in a year, we actually have to add in this factor of n in the exponent also. So that's how we modify our formula. So how do you figure out the value of n? You're going to have to read the problem carefully to determine the value of n. So if the interest is compounded annually, that means n equals 1. Quarterly means 4 times a year, so n is 4. Monthly is 12 times a year, so n equals 12. Weekly is once a week, so n equals 52. Daily is every day, so that means we have n equals 365. So now let's look at some examples. Lucy deposits $500 in a savings account that has 3% interest compounded monthly. Okay, so that's telling us the value of n. How much money will she have in their account after 10 years? Okay, so let's start off by labeling the values. A represents the initial investment. So in this case, that's going to be $500, right? That's what she starts off. N represents the number of times it's compounded. So since it's monthly, that's going to be 12 times a year. R represents the interest rate, so that's 3%, which we're going to go ahead and convert to a decimal by moving it 2 places to the left. So that's equal to 0.03. And so then how much money will she have in her account after 10 years? Well, that's going to tell us the value of t. So we have t equals 10. Now we need to take everything and plug it into our formula. So we have y equals 500 times 1 plus r, which is 0.03, over n, which is 12, and that's raised to the nt. So n is 12, and then times t, which is 10. So one thing to keep in mind is that you have to put n not only in the denominator here, but you have to put n up here in the exponent. Okay, so that's something very important to keep in mind. Now I'm going to go to my scientific calculator to help me perform this calculation. So I have 500, and then I do parentheses, 1 plus, and then I do 0.03 divided by 12, and then I'm going to close that parentheses, and then do my exponent. And then my exponent, you can write it as 12 times 10, or if you want to go ahead and multiply that and get 120, either way should give you the same answer. Okay, so you can see here, it's $674.68, right? I'm going to round to the nearest cent because I'm talking about money in this account. So $674.68 is how much you will have after 10 years. So now let's try this problem. It says that Juanita deposits $4,000 into a savings account that earns 2.75% annual interest compounded quarterly. If she makes no other deposits or withdrawals, what will be her balance after 12 years? So let's first figure out what we have in this problem. So we have the initial value, which is A, so that's $4,000. And then we have the value of R, which is 2.75%. Remember, we need to go ahead and convert this to a decimal. Even though there's a decimal originally in it, remember, this is still a percentage. So we need to move the decimal 2 places to the left. So this is now going to turn into 0.0275 when we plug it into our problem. And so it says compounded quarterly, which means n is going to equal 4. And then it says 12 years, so t is going to equal 12. So now let's plug everything into our formula. We have y equals 4,000 times 1 plus 0.0275 divided by 4, And that's going to be raised to the n times t, so the 4 times 12 power. So let's go ahead now and plug this all into our calculator. So we have 4,000 parentheses 1 plus 0.0275 over 4. And then we're going to close the parentheses and raise that to the 4 times 12 power. Okay, so we go ahead and hit enter, and it tells us that she will have $5,557.59 in her bank account after 12 years. So now you can go ahead and pause the video and try doing this example on your own. Okay, so in this problem, you should have gotten approximately $4,704.68. Okay, so how do we get that answer? So it says they invest $3,000, so that's our value of A. 9% converted to a decimal is 0.09. Compounded daily means n equals 365, and then 5 years tells us that t is 5. So we have 3,000 times 1 plus 0.09 over 365, and 365 once again appears in the exponent, right? Because we have 365 times 5 as our exponent. We plug that into our calculator, we get $4,704.68. So remember, you can perform calculations that involve compound interest using a variation of the exponential growth formula, which is y equals a times 1 plus r over n to the n times t.